All right, good morning, ladies and gentlemen. As you just heard, I am recording today. And you, who sits by the fire blanket, what day is today in terms of students population? Today is an A day for those of you listening. See, I did what you asked. What?
Nobody's watching.
Yes, they are. They're watching.
It's not live.
It's live enough. Anyway, did everyone have a chance to watch yesterday's video? Good. I hope you did. As I mentioned last week, this is going to be a very busy week in terms of material. Okay, not that the discussions themselves are going to be long. In fact, tomorrow's is pretty short. It's just we have a lot to cover. As you were going and doing your Section 2 note summary, you probably saw that there is a lot to go over in this section. And like I said before again, like to go over each individual type of formula, type of setup on their own. Okay, I don't like to cram everything in there. Also, for today's discussion, you will need to have your formula sheet ready. Okay, you're going to have your formula sheet ready. And everybody has the materials, right? Have you checked the materials? No, yes, no, maybe so.
Not.
So you question it just as much as I do. I can't ever remember who gets what. So you should have the PowerPoint. Okay. Good. It's hard. I need one of those wireless microphones. I actually started looking those up to see because I hate standing so close. Okay, I need to do a test to see just how far I can get away from the microphone and still be clear. Okay. So yesterday we got to get into a very familiar equation, acceleration formula, right? You had that in intro. Okay. For some of you, that was many moons ago. But so it should have just been extra little practice yesterday. Also, before I continue on, don't forget that your problem banks, they're all ready to go. But actually, I don't know if I put yours up there yet for today, but I have it ready. They aren't due until Thursday by 11:59 p.m. Okay, so if you have something come up, you can take a night off of it or whatever. Just don't stress. What's that? Your internet goes out. Yes, very good. Which is good timing this week for that to happen, at least in my class, because you have some days. Is it working now?
Yeah, I didn't get home until like 11 o'clock.
Doesn't Chick-fil-A know that you have to do schooling?
I don't know. I didn't get off till like 10.
And doesn't your employer also know that I really enjoy their breakfasts? We were actually in Evansville, Indiana this weekend, and our hotel's right across from Chick-fil-A there. Tried getting there in their line, but their line was wrapped around their building a minimum of one time. It actually took 40 minutes to get through. That's saying a lot about how crowded that was. If Chick-fil-A took 40 minutes. So we ended up going to a competitor just down the street because I was getting hangry. So is your work saved? It doesn't save? Oh, boy.
The internet That game's so fun.
Oh, that stinks. Not gonna lie. That is unfortunate. But you've got some time. And yesterday probably didn't take too long to get through it anyway, right? Well, stay off the cell phone, stay off the Snapchat. Okay. All right. Today, what we're going to talk about, we're going to get a little more involved. Okay. Now, yesterday we looked at acceleration dealing with velocity and time. Today, we're going to include those into some additional stuff when we're also going to have to calculate displacement. Okay. So, what we're going to be covering in this section is motion with constant acceleration. That is the key phrase that we need to keep an eye on when we are doing these problems. Okay, constant acceleration. When velocity changes by the same amount during each time interval, that is when we say we have constant acceleration. So, in the next slide, we are going to be looking at the formulas that are dealing with displacement, time, velocity, constant acceleration, all the fun stuff, okay? And in fact, there are 2 columns of formulas. And I'm going to give you some time to write these down, okay? Can you read those? Or can you at least read them? If you're in the back, can you read those from your notes? So I actually do not think they're in your book. So if you need to come up front to write these down, what's that? Okay, are they? I did a quick glance yesterday. I saw the table with the pluses and minus signs. I just couldn't remember if that was in there or not. But anyway, one thing you need to remember is, this formula, you're all trying to find the same thing. But those formulas in the right-hand column, those are when your object is starting from rest. Okay? Those in the left-hand side is when your object has an initial velocity. So you're either going to be slowing down or speeding up with the initial velocity. So this is where it gets really important for us to really read the question carefully, pick out what is necessary, and off to the side, organize and give values to the variables, okay, that we know. So I'll give you a little bit more time. Once you've got them all written down, if you just face forward, I'll know that you were done. If you're watching this video at home, now might be a good time to get a glass of water, fast forward, or maybe you're copying down. Kind of fun talking to people. This one right here? Final velocity. Okay. Yesterday was a bell work day. It was exhausting yesterday. So I didn't find really get a good look through it. Everybody good? All right. So let's take a look at this problem here. Okay. A racing car reaches a speed of 42 meters per second. It then begins a uniform and negative acceleration using its parachute and braking system and comes to a rest 5.5 seconds later. Find the distance that the car travels during braking. All right. Let's switch over to my cam here. Let's see if I can. Okay. All right. So, looking back at the question here, okay, let's start listing what we know. Okay. So, what's one thing that we know? What's one variable that we know? So, did not want to write that. So you said 42 meters per second? Okay. So 42 meters per second velocity. Now, would that be final velocity or initial velocity? Initial. What else do we know? Okay. So what's important out of there?
It's the change in time.
Okay.
5.5 seconds later.
Okay. And then what else? There's something else hidden in there. It's not necessarily stated.
Then the final velocity is 0.
Exactly. So it comes to a stop. So we're trying to figure out how long or what the total distance was that the racing car traveled as it was stopping. Okay. So of those formulas that you just saw, which one might be the best choice? In my opinion, just throwing it out there since this is our first one, I'd go with that first one. Okay. Where it's delta x is equal to 1/2 VI plus VF multiplied by delta T. You agree?
Yes.
Okay. So, do we have to do any rearranging of this formula? Nope. It's already set up exactly how we want. Again, the reason why we chose this is because this formula includes everything that we have been given. Okay? And it also includes the unknown. So, plugging in our information here, VI was 42.0 meters per second. VF was 0. So I'm not even going to put that in there, if that's all right with you. Okay? And our time was 5.5 seconds. And so, when we place that in our calculators, we should get what for an answer? $115.5. What's my meters per second? Now, if I were to say, give me this in sig figs, how would you do this? 5.5 seconds only has 2 sig figs. 120, so we'd have to round up. 120 only has 2 sig figs as well. Okay? And I'll be really honest with you. After that first chapter, I always am somewhat more lenient on the sig figs. Okay? Obviously, that first chapter is pretty sig fig heavy. So, I do recommend that you continue that practice because most of my answers that I have are in terms of sig figs. So, continue that practice. What I want you to do is open up your textbook to page 53.
I'm not
crowdsource this
spacing my
information.
backpack. Make him sing.
Crowdsource this information.
Yeah.
We'll see. We'll see. Let's look at number 2. You in the center. Will you please read number 2? Now I'll read number 2. That way we can hear it on the mic. When Maggie applies the brakes of her car, the car slows uniformly from 15.0 meters per second to 0.0 meters per second in 2.50 seconds. How many meters before a stop sign must she apply her brakes in order to stop a sign? So what I like about this particular section of this book and what we cover is this problem right here. It's giving us basically almost like an engineering type scenario. If you're going a particular speed in this particular car, or I should say velocity, how long would the person have to stop prior to coming to a certain point? Okay, so these are types of things that you would take into consideration when you are an engineer, if that's where you're going. Okay, so many things like calculations like this go into the thought processes and development of so many things, almost everything that you can think of that you use on a daily basis. All right, if you haven't already figured it out, we are going to be staying centered on this particular formula today. So let's start picking it out. So VF, VI. Let's see if I can't lighten this up a little bit. There we go. VI, delta X, delta T. Okay. So give me a bit of information that we are told. Okay. Because we are coming to a stop. Okay. What else? Okay.
Overall time elapsed is 2.5 seconds.
And we're trying to find out how long we need to, beforehand, do we need to start applying the brakes. Okay. So again, going back to the formula we just saw. We can, now that we've given values to the variables, we can start plugging it in. So go ahead and plug this into your calculator, and I'm going to ask for a volunteer, or I'm going to volunteer you. With the sig figs. Oh, I see you, but long sleeve blue shirt. I would say your name, but I don't want to say your name on camera.
18.8.
And what is your unit? Very good. 18.8 meters. Again, that stays with the number sig figs. 15.0, 2.50. Both have 3, so you answer in 3. Okay, so that was a kind of a repeat of our example problem here. Let's do something where we have to switcheroo some things around here. That's where we get 3 and 4. Okay. Number 3, a driver in a car traveling at a speed of 21.8 meters per second sees a cat 101 meters away on the road. How long will it take it? Let me read that again. I know read. How long will it take for the car to accelerate uniformly to a stop in exactly 99 meters? Okay. So, got a lot of stuff being thrown at us in this particular scenario here. Okay, so let's start off by, again, picking out what we need to know. What do we know?
Initial velocity 21.8 meters per second.
21.8 meters per second. Okay. That was really sloppy. That says 21.8, I promise you. What else do we know? Right up here, white shirt, hand on our chin.
Can you see the cat 101 meters away?
Okay.
So that would be. So 99 meters would be the displacement.
Exactly, because we need to stop at 99 meters before we hit the cat, right? That would be bad. So 99 meters is our distance that we need to make sure that all this happens within. What else do we know? Exactly. Come to a stop. Okay. So if we were to use this same formula, again, I'm the person who likes to do everything beforehand, like rearrange it before. You might be the individual who likes to put everything in to the formula and then rearrange as you go. Perfect, up to you. It doesn't bother me. But this is what we need to solve for, right? Delta T. So what we can do is if we divide both sides by VI plus VF, we will get delta X over VI plus VF is equal to 1/2 delta T. And what do I need to do to get rid of that 1/2? Multiply by 2. So then we get delta T is equal to 2 times delta X over VI plus VF. And then you can go ahead and put your values in there. Delta X was 99 meters. VI plus VF, well, that's 21.8 plus 0, so 21.8 meters per second. So what do we get? Okay, try to keep it in sig figs. All the way back yonder by the whiteboard there. 9.1 seconds. Questions on that one? One more example here. We're going to number 4. Number 4 says a car enters the freeway with a speed of 6.4 meters per second and accelerates uniformly for 3.2 kilometers in 3.5 minutes. How fast in meters per second is the car moving at this time? Okay. This one is I would say, our most involved question yet. Okay. So again, let's write our givens. Okay, our known. What is something that we know? We know that our initial was 6.4 meters per second, right? Okay, what about our displacement? 3.2 kilometers. But what's the issue there? It's in kilometers. So again, if you reach back, do a quick conversion. Okay, meters over kilometers. What values go where? 10 to the third meters in 1 kilometer. So we get 3,200 meters. Okay, what else do we know? Time is 3.5 minutes, which converts to 210 seconds. So now I've got everything in the appropriate units that I'm looking for so I can cancel out when appropriate. So we're trying to figure out how fast the car is moving after this given amount of time. So again, delta x is equal to 1/2 vi plus vf plus delta t. We are solving for that. So let's start rearranging here. Let's first take both sides divided by delta t. So now we have delta x divided by delta t is equal to 1/2 times vi plus vf. I'm going to go ahead and get rid of the 1/2 on both sides as well. So now I got 2 times delta x or delta t equal to vi plus vf. The last thing I'm going to do so I can solve for vf, subtract vi from both sides. And lastly, I get my formula rearranged to where I have vf is equal to 2 times delta x over delta t minus vi. Now I can finally put stuff in here again if this is the way you approach it. So vf is equal to 2 times delta x, which is 3,200 meters, divided by 210 seconds, minus our initial of 6.4 meters per second. So how fast is the vehicle going? Back corner? 24 meters per second. Very good. So those are the type of questions you're going to see. There will be some questions kind of throughout this week that look like they are a portion from a novel. So you get some interesting facts from the questions themselves, but a lot of it is just unneeded in terms of mathematically solving it. Okay? Any questions? No? All right. So I'm going to go ahead, erase this, and then I'm going to say adieu to our viewers watching this at some point.